can easily airdrop to me.
Okay.
Alright, let's airdrop your revision materials to me. So that means your friends are getting it. So which means you are not getting it. So I guess like you have close contact with them.
I never took an art test.
Oh, okay. So all right.
I don't know.
Okay. Yes. Okay.
They never asked me to.
Okay. So you're close friends. So I guess you have very close contact with them. You play with them, right?
Not really close actually. It's actually
okay.
really like classmates.
Okay.
Is it I can only
AirDrop? No. Yes.
share with me email.
Oh, okay. Then never mind. Then okay. It's okay then. Okay. So screenshot and AirDrop.
Okay.
Then I just put it over here. By the way, the x cubed minus y cubed, is this tested for factorization?
It was a practice. It's not really tested in any of the mock papers they gave.
Okay.
Yeah, that's also another question I wanted to ask you.
Okay, then let's start with this that one first. So have you figured out the x cubed plus y cubed question?
Nope.
How do you factorize this?
You say take out
Yeah,
the common.
no. I mean, let's not talk about those questions first. So you just get these out first. Get this out. Oh, plus. Sorry, get this out. So you have x plus y, and then you have this x plus y square, right? So you split this cube into 1 and 2 for the power. Then you continue. So you do the x square plus 2xy. Yes.
Plus y square.
Okay. Then you continue.
So x cubed.
Yeah. So hold on. Let me just change the color. So the most important thing is do it step by step. Okay. Never rush. If you rush, then it's very easy to make mistake. Alright. So you get x cubed
Plus yx square.
plus 2. I mean, second arrow is 2x square y, right?
Yeah.
Then
xy square.
yeah, xy square.
Plus
Then
yx
square. Hold on. So it's yx square and then
plus 2xy square.
2xy square, 2xy square, then plus
y
y cube. Okay. Then you see if you have opportunity to combine things. Okay. So underline similar term. Okay. So I use a different color.
The xy square.
So this one is similar to this is x square, right?
It's
similar to this.
Yeah.
Then this is similar to this. So yeah, you can then you
X
try
cube
to
plus
rearrange
y
them.
cube
You try to rearrange them. Then you combine the
3x
3x square y plus 3xy square. Yes. Yeah. So you have to do it very carefully.
Yeah.
Okay. So once you get this, I think things are pretty easy. Can you see that your x cube plus your y cube is equal to x plus y cube minus 3
minus y minus x
minus. I just bring it over. I bring this thing over.
Then isn't that supposed to be?
I bring it over.
Okay.
So then I bring it over so that I isolate this x cube plus y cube. That's what the question wants.
Oh, so then
right?
Yeah.
Yeah. So you just give this as the answer.
That whole like expression.
Yes.
Oh.
Okay.
Okay.
Then probably you can if you want to take the 3xy out, you can. So x plus this. I'm doing the right hand side. I'm continuing to do the right hand side. Right hand side here.
Yeah.
So you can take out the common factor 3xy. then you will get x, and then you get what? Plus y, right?
Yeah.
Okay, so I think you can probably do it better. Take out the common factor between these two, right? Take out the common factor.
So it's x above
So
x squared.
x plus 3 power of 2 for this term, and then minus 3xy, right? Okay, so this is also one answer.
Okay.
Okay, so for questions like the two, let's say you have 8x cubed plus 27y cubed. So basically you just get it into the something cube format. So 8x cubed is 2x bracket cube. Okay, then 27y cubed is 3y bracket cube. So meaning what? Meaning like in this case your 2x and your 3, no, your 2x and the 3y is your x and y in this case. So what is your x cube plus y cube? Is this one, right? So you just replace the x with 2x, replace the y with 3y. Okay? So what I'm trying to show you here, right, is the proof part where I give you the formula.
Yeah.
In fact this is a formula.
Yeah.
So in fact, right, we need to continue from here further.
Oh.
Yeah, so you expand it. So I'm showing you the proof. But of course, during the exam, you're not supposed to like, if you cannot remember the formula, then only you go and do this silly thing, which is the proof. But of course, if you cannot remember the formula, the only thing you can do is do the proof, right?
Yeah.
Because that's the only way you can solve questions. So ultimately I can get it into, so this is similar, so it's minus 2xy plus y squared. So can you see that this is exactly the
Same.
this is the formula. Are you clear?
Yeah.
So basically what I have done here is to show you the proof of this one. Instead of asking you, hey, just take it on faith, just trust me, take it on faith, I have shown you the proof. How do you end up with this, the right hand side? Okay, by doing the expansion and simplification. So which means I have already done this proof for you and you are convinced. So from today onwards, then you start to use this. So you just take it as a formula. Are you clear? So if the plus will give you this, what do you think of the minus?
Minus.
So we can just quickly just go to the Google. Then Google will give us the answer. Yeah, over here. Over here.
Oh,
Okay, so just
x
crop it out.
y.
Let me just crop it out. So you don't have to go through yourself. Okay, so what is the thing that you need to take note? So if it's plus here, right? Can you see is x plus y for the first bracket, and then for the inside one is minus xy. So for the x cube minus y cube is
X
minus y first. Then inside is plus.
Plus.
Okay, are you clear?
Yeah.
Yeah. So it's a very I will say they are very handy for you next time if you need to make use of this. Alright, so the question, let me just go through one of the question and then you should know what to do with the rest of the question. So let me just take the minus. So let me take the 2x cubed minus 54y cubed. Okay? 2 and 54. And I need to make use of one of this. X cubed minus 54y cubed. So what I see is 2 is common. right? So the first common factor is 2. I take out the 2 first.
X cubed.
So this is 27, right? So the next step is get your this into the cube format.
So it's
still not cube format
X.
yet. Minus 3y bracket cube. Okay? Then now you have it already. So can you see that you can employ this? So you replace your x with x. Can you see? This is your. So basically you replace your x with x, you replace your y with 3y. So the next step is, so what you remember is x cubed minus y cubed is x minus y first for the first bracket, but in this case it's 3y, right?
Yeah.
So the most important thing is always write these 2 down first, so that you can always refer to it. Don't try to get it from your brain, because I think it's going to like clog up your brain. Okay, so try to write things down so you can always refer to it. So the next bracket will be x squared, then plus xy, right? Xy is x times this, so it's 3xy. Then it's what? Plus y squared, so it's plus 3y bracket square, so it's 9y squared. So after that, you can just erase this bracket, which is unnecessary. So this is the simplification or factorization for this.
Okay.
Okay?
Yeah.
Quite easy, right? For the plus, then you just employ the first formula. Okay? So basically these are the 2 formulas you need to memorize. Okay? Then good. So get me the revision materials.
Oh yeah, I tried. I dropped in it. I couldn't see you.
Okay, hold on. Let me just. Okay, now I put it everyone, so it's Mac Mini. You totally don't know how to do it, or just
I
part
know.
of it?
Yeah, especially these simple questions.
Then can you give me a harder question instead of a simple question? Questions that we don't know how to do.
They never give answer sheet, so maybe you can check. The answer.
Okay, check. Oh, okay. It's hard for me to check the answer, but what I can tell you is the approach.
Okay.
You know, right? I always like you to focus more on the approach. If your approach is correct, then it just. I think if the process is correct, then the result will be correct, unless you make silly mistakes here and there.
Okay.
Yeah. So you want to send them in bulk?
Yeah.
Okay.
I'm sending them in bulk.
Alright. Okay, so let's look at them one by one. Save to downloads. Okay, so they are all here.
Yeah.
So let's do the first one, 46 first. Okay, so you have this rectangle. Okay, I find that this is, I think this question I have already given you before, but probably the numbers are just a little bit different. So given that the length is this, okay, over here's the length, and then find the area of the square.
Yeah.
Okay, so you need to make use of the Pythagoras Theorem. That right?
Really?
I'm not sure. I'm asking you. So if this is the length.
You don't have to use the Pythagoras.
Oh, okay. So let's look at it together. I'm not sure. So if this is the breadth, so what you do? You need to find BD, right? So BD is the hypotenuse.
Oh yeah.
Okay, good. So in fact, you divide. Okay, when I look at it, you divide. So when you use, oh, hold on. This is the area, right? So basically, you are telling me use area.
Yeah.
You divide by the length, and what you get? You get the breadth. You get the breadth, right? But this is not the breadth, right?
Yeah.
BD is not the breadth.
Yeah.
Okay, so yeah, so that's the problem, right? Okay, okay. How should I put things so that it won't hurt you as much?
It's fine. I know I mistake.
No, it's not. Okay, I don't just want to tell you this is a mistake. I want to tell you why you make this mistake. Because to understand why, right, is more important than just to tell you this is a mistake. Because if I just tell you this is a mistake, you are going to make this mistake again next time, right? So in fact, I want you to do things like you are teaching someone. Okay, so what's your observation? So when I teach you, right, so what I always do is I always write down the what I use to do that question instead of just write down the answer. So example, if I'm given this, right, instead of just asking you to take it on faith, I show you, right, I show you, okay, the steps, right? So you should do every question like you are teaching someone. Why I say so? Number one, you are showing this. If you are teaching someone who has no idea, okay, the person will ask you why you use this one to divide by this one. It's a valid question, right?
Yeah.
Like, let's say your brother asks you why you take this divide by this. So you will explain, oh, I'm actually using what? Area is equal to length times breadth, right?
Yeah.
So you are trying to use this formula, right? Right? Then continue. Then that's why you say the breadth is equal to area divided by the length, right? And then you start to do it. So basically you put in this, and then you divide by your square root 3 minus 1, right? And then you will get the answer, which is let me just take this as the correct answer first for this division. Take it on faith. Then you will realize, hey, this is the breadth, right? Go. So this is equal to 3 square root 3 plus 4. Then you will realize, oh yeah, I'm doing for the breadth. Well, I'm supposed to get the BD, which is the diagonal, which is called the hypotenuse, if you don't know.
Yes.
Okay, so you see, so in fact, right, there are a lot of opportunities for you to make mistakes. Okay, there are so many opportunities for you to make mistakes. The reason is they are more complicated. When you reach Sec 3, they are more complicated and more steps are required. So it's very easy for you to make mistakes. Not only for you, for all students to make mistakes. So the most important thing I realize, you should show, that's why I keep saying, you should show every single step. You did not show steps here. When I say you did not show steps, it means I look at this. I don't even know why you divide.
Oh. So you mean I should show.
So you should at least tell me, okay, you are actually using area equals to length times breadth.
Oh.
You should write down the formula. Okay? And then when you have the area, so let's say you write down the formula, and then you just show this. I think with this written down, you will not make this mistake already, because clearly the breadth is equal to this answer, right? Then when you have the breadth, then you try to write the breadth out. Then you realize, oh, BD is not the breadth. But anyway, this is the first step. So once you get this, then you make use of the Pythagoras Theorem. So it's this
Square
plus
B square. If I still remember.
equals to BD square, right?
Yeah.
So never skip this step. Okay? Then of course you should know what to do, right? So you just square, so don't try to solve it first. Write it down first.
It's 3.
Oh yeah, it's 3. So try to write it down first. Don't solve it first. Okay? Write it down first. So this 2 times 3 is 6. So it's 6 times 4 is 24 square root 3. And this is 16. Okay? Then of course continue. Okay? So always show your steps. Meaning, like, don't try to take shortcut. To me, this is a shortcut. When you take shortcut, right, you tend to make mistakes. Okay? So that's how you do this question. And then they say what? Find the area of the square. So once you get the BD square, and by the way, later you still have to square root the entire thing. So let's continue. So don't skip step first. Minus 1 BD squared. Okay, then continue. So you get this, you can use a pencil to show you need to square both. So it's 9 times 3 is 27. Then this is 3, this is minus this is 1. So okay, I just write left hand side. So I don't have to keep writing the BD square. It's easier, okay? So underline similar term so that you will not be distracted by so many terms. So 27 3 is 30, 30 plus 17 47. Then you have this 20 24, so it's 22 square root 3. Okay, then this is equal to your this BD square. So how we continue? So most likely you will say you need to square root this, right?
Yeah.
Yeah, then you have the plus minus, right?
Yeah.
You have the plus minus, right? Have you learned how to square root this thing?
I think it's just 47 square plus.
BD square is this.
Yeah.
So what if I ask you for, okay, over here what they ask? They want to find the square, the area of the square, right? Oh, so yeah, so this is the answer. So I thought you are asked to find the,
Oh yeah, because square root
yeah.
square of find the area of square is
Okay,
BD
so
square.
this is the answer, okay? I thought you are asked to find the BD, which is not. Okay, so you see, so that's why what I'm trying to say is it's okay to make mistakes, but the most important thing is when you sense that you make a mistake, can you self-correct on the spot? You understand? Okay, so yeah, so that's the answer. So basically you just tell BD square is the area of the square. Okay, so therefore
I say therefore area of the square is the 47 plus 27.
yes. Okay, so you tend to make, okay, so like I say, right, for you the important part is not the concept. Concept wise, I think you are okay or more than okay, but the problem is still those silly mistakes. I will not say careless. Silly means this is pretty silly, right? Okay, all right, so like this is pretty silly. Or sometimes you make mistakes like you expand and you somehow, I don't know why you see this, right? Or mistakes like this. You know what a lot of students will do? Oh, okay, so just now the formula is this, right? Right? So just take 2x minus this, and then what? 2x is square. So it's minus, so it's plus. Okay, so you see, I remember the formula already. So if I remember the formula, the more you need to remember the formula. I don't need this for my rice bowl, right? So you see, this is so wrong. You know why this is so wrong? Because you have to get this into a bracket cube. That's why you end up with a cube root 2x bracket. Okay, so in this case your x is your this entire thing. Okay, not 2x. Alright, okay, good. Next question. Oh, okay, never mind. Next question is here.
Yeah, have you started recording?
Yep,
Okay.
here, screen recording. Okay, I start to see you write comments so that you can easily refer to it. Okay, keep it up. Continue with that.
I wrote what?
You wrote comment for the
yeah,
video
yeah.
so that you know.
Because I was doing your question.
So it's easier. Okay, so this question. Simplify. So simplify pretty easy. You just get the. Okay, so for this, so you just have to so in fact if you are not allowed to use a calculator, so you need to show steps. So you are not showing any steps, so wrong. Without using a calculator, I wonder if without using a calculator, how do you get to 3 square root 80? You did not show the step. So once again, you did not show the step. So when you did not show the step, how you get? You understand what I'm talking about? You did not show step, how you get this?
I didn't.
I can't read. I can't see that. Oh, 3 times square root 18 is square root 162. It's a bit hard for me to see. So I wonder how you see. So once again, if you are teaching someone how you should teach that person, this is this. So that means there is another step or a few more steps to do the conversion. Yeah.
Okay. So is
Yep.
it like?
So you are not showing that. So if you are not showing that, you get penalized.
So it's.
So how?
Is 9 square root 9 multiplied by square root 18.
Probably you want to show this. Okay. Then. Yeah. So with this, let's say with this, step 1, step 2, step 3. Then for someone that who don't know anything but have some mathematics knowledge, then they will start to understand. Oh yeah, so you basically convert the 162 to 9 times 18. Then after that you square root 9 and square root 18, and with a times in between, square root 9 is 3, and then square root 18 is here. So it's easier for the person to digest, right? Okay, so what if I give you something beyond like in the thousands? So how are you going to do this?
Try to find
Yeah.
a factor that can be.
Okay, so basically, right, in fact, this question without using calculator, you have to show steps. Yes. So for this, right, in fact, this question is just off the top of my mind. Like I did not plan it. So what if you are given like 264? How are you going to do this? The step is, first thing first, you should show your prime factorization. So you divide by 2, 132. Divide by 2, 62. Divide by 2, 31. So stop. No, C6. 2, 33. So 3, 11. Okay? So double check. Okay, good. So your 264, right? If you square root it, you are going to end up with 2 to the power 3, 3 times 11. So can you square root this? You cannot. Okay? But what I'm trying to show you is, if you are given a number which is bigger than 162, so it's very hard for you to see it's 9 times 18. They can give you numbers that can be very large. Let me show you. I just did this question with my Sec 1 student early this week. Revision, where's the review? Okay, good. Yeah, it's launching. Okay, good. Yeah. So what if? Can you use your calculator and get this out? 2 to the power 6 times 7 to the 2.
7 to the power 2.
Yeah.
3136.
3136. So what if they ask you to do square root 3136? So you can't see, right? I mean, without looking at that, you can't see, right? I cannot see. I cannot see.
Yeah.
Okay, I cannot tell. So what you need to do, this is called prime factorization.
Yeah.
Yeah, so it's just 1. So you can use the calculator to help you out. So I'm not sure if you can even put a 3. You start with the 2 first. So once you do, right, you keep doing, you will end up with 2 to the power 6 times 7 to the power 2. Therefore, then you go and convert these to, you need to show this step, by the way, huh? Okay, then you square root 2 to the power 6 times square root to the power 2. Then this one you will get 2 to the power of 3. Then this one you get 7. Right? Okay, good. So then it's 8 times 7 is 56. That's how you get 56. Alright? So I'm showing you, you need to show steps. So next time when you do question, don't skip any step. So show every step
So
as if you are teaching someone.
If they say like using without a calculator, so I had to do prime factorization.
Yes, to show that, to show this.
That's a lot of steps then. Because what I usually do.
I understand, but when this is 4 marks, so what do you expect? Of course, you need to do a lot of things. 3 marks? Okay, no, not this question. Okay, 3 marks. Yeah, you should show a lot of steps. Yes. 3 marks. 3 marks, that means you need to show a lot of steps. Okay? Good. So my point is you need to show step. Otherwise I can't see,
So
I can't tell.
Like they don't say
Yeah.
what I do is.
That's why even when you reach this step, right, you are wrong. That's why you are wrong. Okay? That's why you're wrong. So what you're supposed to do is, you're not supposed to do it this way anyway. You should do the factorization. You don't do it the right way, that's why you are wrong.
How come they never teach this at school?
Okay, you don't expect them to teach you every single thing, because they also can't teach you every single thing. They can't cover everything, by the way, in life. It's just like my parents, or I complain to my parents, how come you never teach me how to get married, how to handle with kids? They can't teach you, they just can't teach you, right? So you have to learn, and then try to use the concepts that you learned in the past. Okay, so how do you get this? Don't do it your way. Get it to the fundamental. 2, 81, what else? 3, not 9, huh? When you put 9 is wrong. I'm going to show you why.
Because 9 is not.
9 is not a prime number.
Yeah.
Now you tell me it's not a prime number, that's why it's wrong. But when you do it, you will put 9.
No.
Okay, so never mind. So over here, can you see? So double check. So 2, 162, so it's 81 divided by 3. Okay, good. So you can actually check whether you are correct or not. So 162 is 2 to the power of 2 times 3 to the power of 4. Quickly use your calculator to see if you can get back 162. You use your calculator to check, not to use your calculator to solve questions.
Yeah.
Okay, good. So done. Next, 128. 2, 64, 2, 32, 2, 16, 2.
It's 8.
Okay, so by the way, 16 is actually 2 to the power of 4. But anyway, never mind, I'll continue. So it's 2.
4. 2.
So 128, 2 to the power of 3, 3, okay, 2 to the power of 7. Double check for me.
Yeah.
Okay, good. So far so good. Next, 18. Square root 2 times 3 to the power of 2. Okay? Okay, good. So you are good now. So now do A.
So I show this.
Convert to 2 to the power of 3 to the power of 2 plus. So take this one. Convert it to 2 to the power of 3, 2 times 3 to the power of 4. Then convert this to 2 to the power of 7. That's your first step. After that, what you do, then you can do the simplification. You can square root the 3 square. Can you see? Square root and square is opposite to each other.
Yeah.
So it's 3 times square root 2. So for this one, you cannot. So basically, you just show this. You just show this. Okay.
I thought you can just.
So you hold on. So square root 2. Okay. Then of course continue. So 12 on top, square root 2 below, plus. So you can use your calculator, but I think I can manage. This is 2 to the power of 3. Okay, you can use your calculator to help you out a bit here. Okay, so let's continue. So it's 9 square root 2 minus 8 square root 2. So you can rationalize the last part. Okay, because show every step. Okay?
Okay.
So, or in fact, you can actually solve this first. It's 1 square root 2. So, 6. So it's 5 square root 2. So the answer is 5 square root 2. That's why I say your answer is wrong. Your answer is wrong because you never use the prime factorization. That's why you end up with this. This square root 18 and square root 8, in fact, you can simplify it further. Can you see this? And then you can simplify it further by square root
So it's
9
3 times
2 minus 4 square root 2. So you get 3 square root 2 minus 2 square root 2, and then it's 1 square root 2. Yes.
Then the other.
No. But okay, over here, right? I just take this part only.
Oh.
Okay. So basically, you should 5 times this, 4 times this. So you end up with 15 square root 2 minus 8 square root 2, and then you end up with square root. But anyway, you are wrong. That's why I say you are wrong.
Okay.
You never use the prime factorization. You never basically, right? The the concept of surd, right? The concept of surd, right? Let's say they give you anything. They give you, let's say, 18. The concept of surd is you need to get 18 into the prime factorization. Okay?
Okay.
So this is the prime factor. I stop. So 18 is actually 2, 3 to the power of 2. Then after that,
So do I do this even if
yes, you better do this. Okay, it's 3 square root 2. So that's how you can get into the simplest form. If you try to do it another way, right? You cannot manage if you are given a bigger number. You just can't. And you will get it into a form that is not simplest. Like this. You are not giving me the simplest. 3 square root 18. This is not the simplest. Wrong. Wrong. This is outright wrong.
Okay.
Okay? You know why it's wrong, right?
It's not the simplest 18.
Yeah, it's not the simplest. And you still can simplify it further. So that's why I say you are wrong. So the fundamental to do this question is always use the prime factorization. And then get it to this format. Then you can use your calculator. Okay, sometimes people, they make mistake here. So you can somehow use a calculator to check. Okay? Some people, they can put 2. I don't know. Because of some reasons. Okay? But always use your calculator to check. Cube root, same thing. Okay? Cube root, the same thing. Cube root, square root, doesn't matter. The technique is, the approach is always this. So once you get this already, then you can solve the question easily. So without using the calculator, find the value of m. Same thing. So I don't understand this. Okay, so you try to times this. Then you try to, is it like you try to do this? You times inside? Okay, good. So times inside. Okay, I start to understand. Yeah, show every single step. Okay, good. So instead of writing this all the time, just left hand side. Save you some time. Okay? So you don't need to keep writing the right hand side. Okay? So do this, and then after that, once again, you never, okay, it's a good habit to use prime factorization. Okay? So 24 is what? 2 times 12, right? Then 2 times 6, right? So it's 2 times 2 times 2 times 3, right? Yeah, so it's 2 to the power of 3 and 3. So over here is a square root. So you need to square root this. So square root this, then you should get 2 to the power of 2, 2 times 3. So this one is 2 square root 6. So it's 2 square root 6. So that's how you get 2 square root 6.
Okay.
Okay? So I think after that, then this one is fine. Hold on, I don't understand this part. how do you transform it? Probably you try to times the square root 3, right? Show it.
Okay.
Show it. Can you show it? Okay. If you don't show it, you will make mistake. Tend to make mistake. Okay. Then for this, okay, this one is fine. Okay, good. So this is 3 times 12 is it should be 36, right?
Oh no, it's because then because 54 I changed the.
Okay, never mind about it. So you should show every step. Otherwise, it's very hard for me to see. If it's hard for me to see, I think it's hard for your marker to see, and then it make life hard for so many people. Then they will make life so hard for you. They will penalize you. Okay. So anyway, so just do it step by step. Show every single step. So this one, take it out is 12. So you simplify this, you get 6 over square root 6 for the first one. Gone. So for this one is 36. 27 square root 6, right? Gone. So for this, 2 on top, so minus 2 square root 6, right? Then of course, then you think of what? You think of I need to rationalize, right? You need to rationalize this, right?
Yeah.
Okay. So actually you don't have to.
Yeah.
Do you have to?
No.
Is it m over or m? What is the question? Oh, okay, good. Yeah. So you just square root everything here. Show every single step. Okay? So you end up with square root 6. Right?
Okay, yeah.
Yeah. Then you then you do the show every single step. That's what I call show every single step. Okay? So then this one you will get 36 square root 6, and then you get 27 times 6. Can you quickly? Okay, never mind. Just write it like this first. Can you help me out with this? 26 or 36 divided by 27 times 6. Yeah. Quickly just get this out.
It's 2 by 9.
Okay, good. So it's square root 6 plus 2 over 9. Square root 6 on top. 1/3 square root 6. So just take the square root 6 out. You get 1 plus 2 over 9 minus 1/3. So just this is your m. Can you do it?
Oh, so.
Yeah. Right?
Yeah.
Yeah. Can you keep pace?
8 by 9.
It's 8 by 9. But even though your answer is correct here, but there are a lot of things that you need to improve on. Okay, for me, the answer is not as important. Okay? Because this time round, you might get the answer. Next time, you might get the wrong answer. Because a lot of things here you need to improve on. Especially show the step. Okay? By the way, do you know how I get all this? This is 1. This is plus 2 over 9. This is minus 1/3. That's why I try to take out the common factor square root 6. That's why I end up with.
Yeah, I understand
Right?
that.
Okay, good. So that's how you get your this. By comparison, m equals to this. Okay? Good. Next. Can you solve C? So square root.
Oh yeah.
So have you done square root before? No, right? So you need to square both sides. Show it. Show it. You did not show it. You did not show it.
Okay.
If you don't show it, like someone who don't know, then will question why. What is this? How do you get rid of the square root? You see, you tend to skip steps. This is what I mean. You tend to skip steps. Show it next time. If you don't show it, your teacher will penalize you. Then once you get this, then you can use your calculator or what?
Or quadratic formula.
Yes.
Oh yeah. So yeah, I asked my friend actually.
Continue.
So then in maths only they taught quadratic formula, but in AMAX they didn't teach. And also they've never used quadratic formula in AMAX. So
How many ways you can solve
yes,
quadratic equation?
factorizing.
Yep. Can you factorize this?
No, I already tried. It's
Okay.
in decimal.
Let me just take it with faith. Cannot.
Okay.
Okay. Factorization. Cannot. What else?
graphical method.
Graphical? Are you did you say graphical?
Yeah.
Okay, good. Go. Anything? So not
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 best.
possible. So not the best here. Okay, good. So assume no for this question. No.
Complete square.
Did you try complete square?
No.
Okay. So you see, you have complete square to do it, but you never do it. So of course then
Correct.
formula, right?
Mm-hmm.
Of course calculator.
Calculator.
Yeah. So I mean calculator can give you marks, might not give you full marks. So what if you are desperate? Then you use a calculator. But you need to use complete square in this case.
That's it. I was like, why? I didn't think of complete square.
Yeah, you always probably you. I can't say. Okay, let's be nice. So that just you need to tell yourself you can use any of this. Okay, so factorize you say cannot. Okay, I assume can. And graphical not recommended in this case.
Mm-hmm.
Okay, so complete square. Over here. Oh, by the way, for complete square, give yourself a middle bracket. Put the 4 out first. Why you need to put the 4 out first?
Because I don't know. Actually.
Can you not put the 4 out before doing complete square?
I don't think you need to.
No. The key thing for complete square is you need to make your this 1.
Mm-hmm.
You don't Now you but just now I asked you why, you said no need.
Actually, no, because whenever I write, I just write the 4. Then after that, I plus something else to make it into half, negative half.
No, wait. I say why you need to take out the 4.
So that the x square must be 1.
Yes, the coefficient of x squared is 1.
Yeah.
Just now I asked you this question, why take out the 4, and then you say no need actually.
Oh, I thought you mean why you need to put bracket. You don't need to put bracket.
Actually, you need to put a bracket.
The second bracket.
Oh no, you need to. I mean it's up to you, but it's best to put, because later your 4 will come in.
Oh.
And you see, okay. You did not answer my question, and then this one you answer wrongly also.
Okay.
So it's needed. The bracket is needed because it's going to come in later. The 4 is going to come in later.
Because I thought that once you square the x square minus half, then after you multiply that, then you add or minus whatever comes after.
Okay, by the way, I don't recommend you not to put the bracket.
Okay.
Okay, because you know you are supposed to take out the 4. So the 4 should be isolated at first from this, right? So that's why try to isolate the 4 and do the complete square for this. So now over here you will get plus 1/4, right? So how you have a extra plus 1/4 here. So how are you going to compensate? So you need to minus 1/4 minus half. There is no square here. So this is 3/4. Then now your 4 start to come in. Are you clear? Then you equate to 0. Are you clear? So basically all here you can write right hand side. Then you just bring the 3 over. You should end up with 2 answers. So x is equal to how to do it? Square root plus minus. Right?
Right.
Then x is equal to plus 3/4. So minus is plus. So or x is equal to minus 3/4, then plus. Okay, so then you get your two decimal places or three significant figures.
Okay.
Okay, so this is one way. Of course, you can use the formula. Who says you can't? You can. You can.
Okay.
Okay.
But I was just a little skeptical because in Amex we've never used it.
No, there's no such thing as okay. I learned it from physics. I can't use it in mathematics, or I learned it in mathematics. I can't use it in physics. There is no such thing. It's just in life. You apply anything that works, right? You cannot say, hey, I stay in school. I can only do this. At home, I cannot do this. No such thing. Okay? This is called the interoperability. Yeah, something like that. If you can operate here, you can operate elsewhere as well. Okay? But anyway, I don't want you to use formula because I want to emphasize you can always use completing square.
Yeah.
Okay? Of course, in this case, I prefer formula. Why? Because completing square takes some time. Why? Because actually, once you get fraction, right, you try to avoid using completing square because it's going to be complicated. I mean, not too much, but still quite complicated. All right? Yeah. So that's it. So you should use formula. All right. Next. Then is this the next question? Oh no. So it should be 48. Okay, good. So once again, by the way, they can choose not to give you this. Okay? But okay, so can you see what format is this? This is the dividend is equal to remainder
remainder plus quotient times.
Remainder is here.
Yeah.
Quotient is here. So you need to put things in their proper place. You don't remainder plus first. Okay? If you put it not in the proper place, you're going to be wrong. So what first?
Divisor.
Correct.
Times.
Or factor first, right?
Yeah.
Times quotient plus remainder. Right? So you see they already give you in this format. So you don't have to.
Yeah, it's because you need to find the A.
Yeah,
B,
good.
and C.
So you need to sub based on these two. You need to sub half in. You need to sub minus 1 in. Right?
Why?
Okay, of course you can use comparison. Are you using comparison here?
Yeah.
Yes. What if you don't? What if you don't? Let me show you. I'm showing you another approach. You are using comparison, right?
Yeah.
Okay, good. Let me show you not comparison method. Because this is the factor, right? This is the factor, right?
Yeah.
So if 2x minus 1
actually no, the
sub
the ax plus b is the factor.
ax plus b is a factor also. This is the quotient. By the way, all these are factors, by the way. I mean, okay, if you look at it, why you think this is the factor but not this is the factor? I can also say this is a factor, right? Right? I can also say this is the factor, right?
Yeah, because they all multiply to get the.
Yeah. Okay? Yep. So you cannot say, oh, this is the factor but this is not. Okay, so I sub in what? I sub in half into left hand side or and right hand side. Right? We used to do this, right? Right? Am I right or not?
Wait, so you sub in half so that you can take away the quotient?
No. The question is not to take away. The question is we always use this, right?
Yeah.
Like sub in something into the left hand side and the right hand side. So
yeah.
So what do you get for the left hand side? So you get 4 cube square minus 8 equal. So once you give the half in, this is 0, right? 0 times this times this. Yes. So you immediately get your C. That's how you get your C.
Okay.
Okay?
But then you have to get your A and B.
So let's try to put a -1 in, sub -1 into RHS. So you put the -1 in, so -1 you put in C also. So basically you cannot continue. So therefore you realize, okay, this method don't work for A and B.
Yeah.
That's why you think of what?
Comparison.
Correct. But once you get your C right, I think it's easier for you to compare. So basically what I'm trying to say, you can get C by using this method, then straight away put in the C, and then you can solve the AB easily. So that means the combination.
Okay.
So what I'm telling you here is, when you get a question, think of this method and
It's
comparison.
like getting a minimum value.
Again?
Like when you sub in that, you get a minimum value.
I don't know what is minimum value.
Remember in sketching,
Mm-hmm.
we try to find the minimum. If it's maximum or minimum.
I'm not sure I'm not sure if you can get the minimum value here. Not true. This is cube. Cube has a lot of maximum and minimum. You try to sketch the cube into the graph, you get a lot of values. Which maximum you are talking about? Now the question is. So I'm just showing you for the quadratic equation. You have only one turning point, but for cube you have many turning points, so you cannot assume that. So let me show you a quadratic one. Yeah, so this is a quadratic, right? So can you see you only have one turning point, which is here, right? So this is the minimum point. You only have one minimum point. What if you change it to cube? Let me make it more complicated. Get it to square. Can you see?
Yeah.
There is no turning point already. So if there is no turning point, any minimum point? No. It will go down indefinitely. It will go up indefinitely. So your understanding of getting minimum point and maximum point for cube does not hold up. It's not valid.
Okay.
Okay? Yeah, good. So try to extrapolate. Extrapolate means try not to like say, oh, if it works for square, then it works for certain situation. It does not work. Okay? But what I want to show you here is, you can get the C immediately, but you can't get the A and B. So use comparison. For this, it's better to use comparison. Next. 49. So for this, okay, good. So this is the one you can use the dividend equals to, so you have the divisor times the quotient plus the remainder, right?
Yes.
Then now you can start to use, so it's divisible. Divisible means this one is a factor. So if x minus 1 is a factor,
Oh yeah. So this.
so remainder equals to 0, hold on, and then sub x equals to 1. Okay, good, yeah. Go ahead.
So this method.
I'm not saying this is not right, this is right, this is right. You are using, probably you call this a factor theorem, or you call this remainder theorem.
My teacher taught me.
Yeah.
So I use her method because I'm doing my school exam. So I tried to get to this.
Okay. This one is correct, this one is correct, but the understanding is from this.
Yeah, yes.
Okay? I informed you before.
Yes.
Yeah.
It's because if we multiply the 1, then the quotient and multiplied by divisor it comes 0, and remainder 0, so it's 0.
You see? Okay, in fact, you sub in the 1, right? You sub in the 1, right? This, you sub in the 1 to the left-hand side. This is your left-hand side.
Yes.
And then you sub in the 1 into your right-hand side, right?
Is
This is your right-hand side.
yes.
What I'm trying to... Wait, why I teach you this one first? Why I teach you this one first? Dividend is equal to divisor times quotient plus remainder. The main reason is for you to understand why. I don't straight away teach you this is because I don't want to teach you just take it on faith. Just trust me. It works. I don't like that because sometimes without a reason and you are asked to do something, you always have this itch. Why? Why I want to listen to you? Right? You are not convinced, right? So I hope with this and your school this is not a school method, this is factor theorem or remainder theorem, you get to understand why. And by the way, when you understand why, right, let's say next time you use your school method, it doesn't work, somehow it doesn't work, what you use?
I use that.
Go back to the fundamental.
Yeah.
Okay, so I start to teach you the fundamentals first, and then when you, so can I ask you, when you learn this in your school, did you have the idea these two method, factor theorem or remainder theorem, they are actually using this concept?
Yeah.
You realize that?
I realized, but then
Yeah.
they never told.
It's okay. So in schools, right, they just ask you to take it on faith. It's just like you go to the church or you go to something, just trust me, okay? Just trust God, just trust. But they never tell you why. And you don't question, okay? Okay?
Okay.
Okay? So I always want you to like go back to the fundamentals. It's like sometimes 18. Okay, just trust me. This is going to be 2. Okay, I don't know. It's 3 square root 2. And then why? Don't know. In fact, you can see this easily, right? What if I give you this? Then you get stuck, right? What if I give you something even worse than the 126? Then how are you going to solve this? You can't use this anymore. So yes, in fact, the fundamental is the prime factorization. All right? Okay, good. Next. So what is this? So the line intersect with this. So okay, this is simultaneous. Yes. So for simultaneous of this, okay, it's good to use substitution. Okay, it's good to use substitution. Did you use substitution? Yeah, you sub in. So you sub in, you get a quadratic equation. And by the way, I don't know how you get this, by the way. How you get this? So once again, I don't know. You get penalized.
So I use calculator. So because I need to take out the y.
Then I will say wrong. I can't see it. Unless you tell me by calculator. Or when you say by calculator, that means wrong.
Oh, why?
Because okay, I'm not saying you cannot use calculator, but this is wrong. 真的 wrong.
I thought in school they say it's fine. I use it.
Okay, let me tell you what. Okay, let me tell you what is that. What is that? That subtle difference. You need okay. You can use calculator, but you need to show that you use calculator in a smart way. This is a very blunt way to tell people I use calculator and I get this. Remember the other time, x equals to 0.5. You have many factors that can give you x equal to 0.5. Can you give me one of the factor that you can get x equals to 0.5?
X minus 0.5 equals 0.
Very good. Can you get other factors?
Multiply, so 2 yeah.
Can you give me a more? I think so. but we can stop here first. Then now my question to you is, given that you have just x equal to 0.5 and you have two possibilities, I will ask which is the one that, then which one is correct? By the way, they are very different, okay? When you say both of them are correct, I don't agree with you. Only one of them is correct.
Is it the second one?
So, in fact, in this case, without further context, both are correct. Without further context. But with further context, only one of them is correct. I remember we picked this the other time. Why? Because they say,
Cannot use it.
no, they tell you the x cube, the coefficient is 2. You remember the other time we have a question like this? You remember that or not? That's why I say, yes, you cannot take this, you should take this. Because this 2x will give you the ax squared. Like when you times, you will get x cubed. You remember that question or not? Last week.
Yeah, because
Okay.
you had to multiply by 2 to get it.
Yes, so you see, so without context, so both are correct. But with context, like that situation, only one is correct. So now I will ask, you give me y equals to half again, right? Can you see? Without context, y minus half is correct. 2x minus 1 is also correct. But which one is correct in this case? In this case, right? So you need to show it in a smart way. And by the way, this is not the way to do it, okay? How to solve quadratic equation? How come just now you tell me quadratic equation, there are many ways, I shouldn't use calculator? That in this case, you go and use calculator. You see your inconsistency or not?
But like if you use calculator,
Yeah.
then
Now when you use calculator, then you will fall into this I will call this dilemma.
yeah.
Okay, by the way, x equals to 0.5, right? There are more than these two possibilities. This is also one possibility. Then if you end up with so many possibilities, then which one is correct? So for this one, right, I can write, I change to y. Then which one is correct? I will question you, why you pick the first one only? How do you answer this question then?
Just say I use calculator.
No, you use calculator, but now the question is, you use calculator, you will get this, and this. Which one you should pick? When in mathematics, I think things are quite certain. There is not much leeway for you to argue, right? But now you end up in a situation where you can have more than one possibility. Something is not right already, right? Or unless you never think of the two, you never think of these two. I think you never think of these two. That's why you just take the first one out of convenience.
It's because like I already take out the 12 out.
Nothing to do with the 12. Now my question is, you tell me y equals to minus half. I challenge you. You can take this. You can even take this. Why you pick this one? Why didn't you pick this? Just change it. Okay, since you talk about y, I change it to y. This one also give you half. This one also give you half. Why you pick the first one?
Because when you're trying to find y, it's anyway at the end product is going to be the same 0.5.
Yeah. So so my question to you is, why I get this? Why can't I get 12, 2y minus 1? Then, okay, just why can't I write like this? Or why can't I write like this? Like I say, math is quite certain. You have very little room for you to have a different answers, right? When you when you are in a situation where you have many different answers, that's not mathematics. Okay?
Okay.
That's not mathematics. Something is not right. So, probably you have not thought of this while doing this. You just take the easier one. This is the easiest to see. This one is hard to see. This one also very hard to see.
Why you put 2y minus 1, then the y plus 2 by 3 is still the same?
No, I understand they can be the same, but are you telling me these three are the same? They are not the same, right?
No.
So what I'm trying to tell you is, when you combine them again, they might be the same, but at this stage, they are not the same. They look so different. And in mathematics, generally, you don't have a few scenarios for an answer. So when you have these few scenarios for an answer, that means something is not right. So stop doing it this way. And by the way, you still did not remember, when you end up with this, what's your first step? What's the first step? Not 12. You don't take out 12. Wrong. Unless you want to do completing square, you take out 12. Okay, why you take out 12? You want to make it make the coefficient 1, right?
Yeah.
That is for completing square. Are you trying to use completing square? No. What is the preferred method to solve this? Factorization, right?
Yes.
Yeah. So before you do factorization, what is the first step? Take out common factor first.
6.
This is the first step. Divide by 2 because it's 0. This is your first step. So the first step is always take out common factor. Okay? If you see opportunity to take out common factor, always common factor, regardless whether it's quadratic or cubic, like you asked me cubic just now. Remember this? You take out common factor 2 first. Right? Regardless, even if I give you just a simple question, take out common factor. It's always the first step when you see opportunity to factorize. So once you take out the 2, you can simplify a little bit. Now with this simplification, then you try to use factorization. 2, 3, yeah, it works. This is the answer. Oh, sorry, the y should be here. I'm so sorry. Okay, then you get your y equals to half. You get your y equals to minus 2/3. Yeah. Okay.
Okay.
So when you look at your calculator, you get this, right?
Mm-hmm.
And you try to force it. You compare. You compare. They look so different. Right?
Mm-hmm.
Your answers are these, and doesn't mean it look like this. Are you convinced now?
Oh. So then if you
What do you end up with if you take this? Y square. Right? Minus.
half.
So never mind about it, but you will end up with y square, right?
Yeah.
This will give you 6y square.
Oh. But
Can you see how hugely different they are?
Yeah, but then if I take out the 6,
You can.
that's what
But
I.
you take out the 6. So why you take out the 6?
So then I can put the y minus half.
did you show me you take out the 6? You take out the 12.
Yeah.
Okay, so but anyway, let's not complicate stuff. I don't think that it's so easy to do this. And I also don't want you to, like, let's say the calculator gives you answers and then you assume it's always this. It's very dangerous. So you immediately, you have that conclusion is definitely this. No. No. It can be. How do you get 2? Okay. How do you get 2? There are many possibilities to get 2. So, how do you get 2?
Y minus 2 or
2 minus y. Right? Right?
Mm-hmm.
I don't want you to end up with questions, end up with answers that has a few possibilities. And that is very controversial. You have your point, I have my point, then we don't reach an agreement. Mathematics is quite certain, okay? It's quite certain. Okay?
Mm-hmm.
You don't put yourself in a situation like later, okay, when you are marked wrong, it's wrong already. You cannot bring the paper and don't get argue. That's why it's better you give the most natural answer, which is you do it this way. There is no argument. You show me the step. Okay, you show me the step. You show me, you do the factorization and you end up with this. Okay, clear. Very clear. Instead of using the calculator based on the answer and you go and create this, it's kind of like hard to accept. Okay? So your calculator only serves one purpose, for you to check the answer. So what I'm trying to say, you don't do back engineering. You know what is back engineering? You don't backward. Okay? You don't do backward engineering. Get the answer and then try to figure out what's the question. You should do this. Okay? Unless you are like having fun. Okay? But during the test you are not having fun. Alright? Okay, good. So stop using this.
So if I take out the 6,
Yeah.
then after that I put the...
You take out the 6, most likely you will end up with this answer.
Yeah,
But it doesn't make sense for you to take out 6. If you take out 6, things are complicated. My question to you is, why you make your life so hard? Yeah. Why you want to do fraction? It's like, we just talk about it. If you end up with fraction, forget it. Don't do fraction. You want to do fractions? I don't. Okay, if you prefer fraction, okay, let me give you one question. You try to argue your way out, okay, fine. Try to do this. Factorization. It's pretty hard. It's pretty hard, right?
Yeah.
Let me make it more complicated. You want to play with fraction? No. In fact, if you are given this question, you want to get rid of the fraction. You want to times a common factor 6, 12 throughout, so that you get 2, 6, 3. Okay? With whole numbers it's easier to calculate, right? And now you argue against just to make yourself feel good about this method.
No, it's because like I've been using this and then it will be like I can't like quickly like turn away from it. It also like
this is the thing we used to do. This is something funny actually. This is so out of the norm. This is quite out of the norm, right? Compared to this. You are so used to this. You are not used to this. This is out of the norm. Okay? So stick with this. You can have fun with this during your normal time. Because you can make mistake during normal time. You cannot afford to make mistake during exam. Okay? Okay, good. So next time, you need to show me 2 solutions. Keep using these, okay? I want to see this during our practice. Next time, quadratic equation, show me this as well as this. And over time, you will slowly give up. Okay, forget about it. I'm done with this. I'm done. Okay? I want you to be convinced. Okay? During exam, use this. So remember quadratic equation. Just remember factorization doesn't work. Completing square doesn't work. Quadratic, I mean the formula.
So then in exam, instead of using calculator, then I use the normal box method.
Yes, that's factorization.
But it takes a while. Like
you mean factorization takes a while?
No, instead of like using calculator, it takes more.
No, you use the calculator to help you out. To guide you. But when you use this, when you see things like this, right, and you try to do back engineering, right, cannot. Generally, if you get a quadratic equation, generally the numbers are quite friendly. If it's too much, let's say I give you this, will I recommend you to use factorization? No. If you get this, I will not recommend you to use factorization, because if I myself, I cannot see the factor, I cannot see the factors. You know what I will do? Quadratic formula. Okay? And I will not use the calculator. I will use quadratic formula. If they give me something like so funny, and until I can't see, I can't see anything, I can't see the factor, I will not try. I will quickly use quadratic formula. Okay? I don't even want to attempt completing square. Are you clear?
Okay.
Okay? Yeah, good. Okay, we can take a brief break, then